Okay, so in this practice, I'd like to introduce the two terms, apparent brightness and luminosities. At first, I'd like to introduce the new term of the apparent brightness. Apparent brightness. We obtain all the information of objects in the sky from light we receive. Apparent brightness of a star is the amount of light from a star we received in a unit area of a telescope per unit times. So the stars is emitting the light, and we happen to receive the sum of the light on the unit areas. Unit area and per unit time. Luminosity is and then luminosity is the total energy of light emitted per stars. So the stars emitted the light in the many different directions, and we sum up all the emitted light, energy of the light, and then we could find out how much energy is emitted from these stars. Okay. The amount of energy received in a unit area is dependent on the distance from a star, and it decreases following the inverse square laws. So the light is emitted from a star. If we place the unit areas in the very close regions, so inside of these cylinders, all the light should be pass through these areas. But if we place this area is far away from the stars, then received energy becomes smaller and smaller. So we call that this is the inverse square laws. Assuming the isotropic radiation of light from the sun, luminosity can be calculated from the apparent brightness and distance to the stars. The luminosity and the apparent brightness is related. This luminosity is equal to apparent brightness times 4 pi r squared. This is luminosity. This is apparent brightness. And this is area of a spheres. With radius r. Because now we consider the star is located at the centers, and then considering the spheres with the radius of the r. Then total areas of the spheres is area is given by 4 pi r squares. So the light from the stars passing through all the directions uniformly, then we could consider the really small areas of the unit areas. Then how much energy is passed through the unit areas is the apparent brightness. So you can understand luminosity is obtained by product of the apparent brightness times areas of the sphere with radius of r. So if you find the two values among the three values, luminosities, apparent brightness, and the radius, a distance from a star, you will find the last ones using the inverse square laws. This is we call the inverse square law. So now I'd like to answer the questions of this practice. Apparent brightness of the sun is measured, so apparent brightness of the sun can be measured on the surface of the earth, 1300 watts per square meters on the earth. Assume that we know the distance between the sun and the earth. So R is the distance between the sun and the earth is 1.5 times 10 to 11 meters. Then we can find the solar luminosities can be calculated. I sub B 4 pi R square. You can substitute 1300 watts per square meters times 4 pi times 1.5 times 10 to 11 meter squares. Then you can find 3.7 times 10 to 26 watts. Okay, this is the answer to this practice.